Example 5, Garrett Hartley kicks off the football at the 40-yard line, downfield with an initial velocity of 85 feet per second and an angle of 56 degrees. How far down the field will the ball first hit the field? Determine the maximum height of the ball. And what is the hang time? Well, a lot of things we're solving for here. Let's start with our component vector. Velocity, t, cosine angle. Velocity, t, sine angle minus 16t squared. Let's first solve for what is the hang time. Now, what that means is, when does it hit the ground? That's all it means. So we're going to go to our y equals portion of our calculator here. Let's clear out the previous data and let's put this in right there. Let's graph it. Looks like this ball is going to hit the ground at, there's x-intercept 1, there's x-intercept 2, there's x-intercept 3, there's x-intercept 4, and there's x-intercept 5. It's falling in between 4 and 5. So second trace, highlight 0, enter, and then 4, enter, 5, enter, enter. It's going to hit the ground. The hang time is 4.404 seconds. Next, how far down the field will the ball first hit the field? Okay, so now we want to figure out what's the distance. How far was it kicked? So distance. So we're going to take our x equals portion of our parametric equation here. 85, but instead of t, we know it's going to hit the ground at 5.404 seconds. Well, I think I might have said that wrong. 4.404 seconds. 4. And then cosine 56. Okay, let's plug that into our calculator. Looks like 209.328 feet. And next, determine the maximum height of the ball. What is our max? Let's go back to the calculator here. Let's pull up the graph. Let's try and figure out what the axis of symmetry is. So it looks like if we kick this ball, like maybe halfway is right about here. Now that to me looks like halfway would be right in between the x-intercepts of 2 and 3. 2 and 3. So let's go second trace, highlight maximum, push enter, and now 2, enter, 3, enter, enter. Looks like our maximum height will be 77.590 feet high. And example 5 is now complete. Example 6, Sebastian Janikowski, a place kicker for the Seattle Seahawks, kicks a football in a game with the Dallas Football Cowboys. The ball leaves the ground with a velocity of 88 feet per second at an angle of 30 degrees. Find the hang time, period, if the ball is kicked from the Seahawks 30-yard line and is aimed straight downfield. Where does it land? Find the maximum height of the ball. Let's set up our component vector. Let's see, velocity is 88, which just so happens to be Michael Irvin's old number, Drew Pearson's old number, and currently CeeDee Lamb's number. T, cosine the angle was 30, comma, 88 T sine 30 minus 16 T squared. What are we solving for again? Looks like a lot of stuff. All these. Find the hang time. Hang time. When does it hit the ground? Let's do that first. Y equals. Let's enter in the Y portion of our component vector. Clear out previous data. 88 X sine 30. Close those parentheses. Minus 16 X squared. Graph it. Let's make sure it doesn't look funky. That's about right. Okay. There's x-intercept 1, there's x-intercept 2, there's x-intercept 3. Looks like it's falling in between 2 and 3. So second, trace, highlight 0, push enter, and now 2, enter, 3. Enter, enter. Looks like it's going to hit the ground at 2.75 seconds. That's our hang time. If the ball is kicked from the Seahawks 30-yard line and aimed straight downfield, where does it land? So distance. Let's find the distance. In order to find distance, let's take the x equals portion of our component vector, and everywhere we see a t, we're going to substitute 2.75. Looks like it's going to land at a distance of 209.578 feet. I don't know how familiar you are with football, but football is measured in yards, which just so happens to be a Pirate's favorite unit of measure. 30 yards. Sorry. Okay, so here's what we're going to do. We're going to take our answer and we're going to divide it by 3. Because there's 3 feet in a yard. Remember? So it looks like it's going to travel 69.859 yards. A football field is 100 yards of distance from end zone to end zone. So if he started at the 30 and then kicked it almost 70 yards, 70 plus 30, that's 100 yards. Let's just say he kicked it right about to the end zone. So if the ball is kicked from where does it land? It lands here. That's about the end zone. And then lastly, find the maximum height of the ball. So we have a max at, go to your graph. Let's try and figure out the line of symmetry here. Right about there. Looks like that falls right in between the x-intercept of 1 and 2. So let's try 1 and 2. Second, trace, highlight maximum, enter. Now let's do 1, enter, 2, enter, enter. We have a maximum at 30.25 yards. Or feet, sorry. Example 6 is now complete. Example 7, Shin Su Chu, an outfielder for the Texas Rangers, is 215 feet from home plate after catching a fly ball. The runner tags third and heads for home. Chu releases the ball at an initial velocity of 75 feet per second at an angle of 25 degrees. Assume Chu releases the ball 5 feet above the ground and aims it directly in line with the plate. How far will it travel horizontally before hitting the ground? Does the ball reach home plate? Set up our component vector. Initial velocity is 75. T, cosine, and then angle, comma, 75 T sine angle minus 16 T squared, but hold everything. Didn't it say that he releases the ball 5 feet above the ground? So we need to add 5 to the y equals portion of our parametric equation. All right, how far will the ball travel horizontally before hitting the ground, and does the ball reach home plate? Well, let's figure out when does it hit the ground. Y equals, clear out any previous data, 75 x sine 25, close those parentheses, minus 16 x squared plus 5, graph. Okay, looks like that is x-intercept 1, that is x-intercept 2, that is x-intercept 3. Looks like the ball is going to hit the ground in between the x-intercepts of 2 and 3. Second, trace, 0, enter, 2, enter, 3, enter, enter. Looks like it's going to hit the ground at 2.128 seconds. Now that we know when it's going to hit the ground, we can now determine how far will the ball travel horizontally before hitting the ground. So let's take our horizontal portion of our parametric equation here. Let's plug that into our calculator. Looks like the ball will travel 144.647 feet before hitting the ground. Lastly, does the ball reach home plate? Well, the plate is 215 feet away. So no. We're just going to go with no. Because, as we know, the ball's going to hit the ground and then continue to roll and bounce. Maybe it reached there, but we're just worried about, does it reach home plate before hitting the ground? So no. And that one is now done. On the 6th hole, Tiger Woods selects a 5-iron. He estimates the distance to the pin to be 200 yards. Woods' swing provides an initial velocity of 150 feet per second. to the ball at an angle of 25 degrees. Will he hit the pin? Component vector time. Initial velocity. T. Cosine. 25. Okay, now let me reread what they want us to solve for. Will he hit the pin? Well, let's figure out when is it going to hit the ground. Y equals, clear out previous data. Let's now enter the y equals portion into our calculator. Graph it. Okay, there's x-intercept 1, there's x-intercept 2, there's x-intercept 3, there's x-intercept 4. Huh. Looks like it might be going right through the x-intercept 4, and then there's x-intercept 5. Now I'm willing to bet it's probably not going through x-intercept 4, but we know it's falling somewhere in between the x-intercepts of 3 and 5. So let's use that as reference. Second trace 0. 3, enter, 5, enter, enter. I told you didn't hit 4 exactly. It's going to hit the ground at 3.962 seconds. Now let's figure out what the distance is. Is it going to hit the pin? Let's take our horizontal equals equation. Everywhere we see a t, substitute 3.962. Cosine 25. Let's plug it in and see where this ball, how far it travels. Looks like it's going to travel 538.619 feet. But wait, we are dealing with a pirate's favorite unit of measure here, yards. So let's divide this by 3. Divided by 3. Looks like it travels 179.539, which would round up to 10. So 179.540 yards. Will he hit the pin? Well, no, because the pin is 200 yards away. His ball lands at 179.54. So we're going to assume that it definitely falls a little short. But since he's so good, it probably hit the ground and then rolled in. So did it hit the pin? No, but it probably rolled in for a hole in one. That's it for that one.